Here at Calc, it's problem 9-32. It says solve for all possible values of theta, and it says sine 2 theta equals cosine theta minus pi. So right away, I remembered that we had a little formula, like a double angle formula, and so I went over here and replaced it, or I'm going to, sine 2 theta. So I think I've got this little formula right here. It's 2 sine theta cosine theta. So I'm just going to use my double angle. What was it again? 2 sine theta cosine theta. And then that's when I got confused because I didn't see, I still had sines and cosines in here. And so I went to the homework help and they gave me a hint to use my difference formula. You know how we have sum and differences formulas? So then that got me unstuck. So I have a difference formula for cosine A minus B. So where is it? It's right here. So it's going to be cosine A, cosine B, plus sine A, sine B. Let's do that right now. Cosine A plus sine A, sine B. Okay, and then I'll just rewrite this over here. Okay. Now I know I can look at my unit circle and get some values for these. So I'm going to go ahead and do that. I think I'm going to have like, one of these is going to be a 0. See this right here, cosine of pi is -1. So this is going to be -1 times cosine theta. So that's going to be negative cosine theta. Now, sine theta times sine of pi. Sine of pi is 0. So that's just going to be 0. I'm not going to write it. It's just going to be 0. And then I'll just rewrite this. I think I can solve this now. I'm going to add cosine theta to both sides. And then I need to have these factored so I can use the zero product property on them. So I'm going to factor out the cosine theta. Plus 1. Okay, now I have something times something else equals 0. So if I multiply two somethings together and the answer is 0, one of the two somethings or both have to be 0. So I'm just going to rewrite it as cosine theta equals 0, or 2 sine theta plus 1 equals 0. This one I can work on a little bit. So I've got this. These aren't my answers, but these are, I'm going to like inverse cosine this and inverse sine this. In other words, I'm going to find the angles, and they want all the possible values. So all the way around the unit circle. So not just between 0 and 2 pi, but all the way. So I'm going to have to do that thing where I say plus 2 pi times n or something like that. So where is cosine 0 on my unit circle? So cosine is the x value. So it's 0 at pi over 2 and at 3 pi over 2. And if I kept going around and around and around the circle, every pi, like it's going to be, here, let me write it for you, maybe it'll make sense. Theta equals pi over 2 plus pi times n. This is the answer, or one of the answers. Why does that make sense? Because if I start at pi over 2, and then I can go plus pi, well, that'd get me here. And plus pi would get me back here, plus pi, plus pi, plus pi, like that. So I could just go forever and ever, and that would give me all possible values of theta. So that's that answer. And then I'm going to get some answers from here. I should get, there's 2 places on the unit circle where sine theta equals a half. Now sine is the y value. Oh, so sine has to be actually a negative half. So it's going to be down here and down here. And your answer book, I think it's wrong. Because your answer book says it's pi over 6 and, I don't know, 7 pi over 6. I think it's 7 pi over 6 and 11 pi over 6. Because that's where sine is negative half. So, and 11 pi over 6. So how do I write this? I'm going to write theta 7 pi over 6 plus, now I can't do that little trick that I did last time where I go around half a circle and keep hitting it. Because like when I hit this one, the 7 pi over 6, that's not half a, I mean, I have to go all the way around 2 pi times. So I have to write it twice like this. I have to go 2 pi times n. So these are the other 2 answers. Your answer book, I think your answer keys are all wrong. Yeah, the 2 pi n, because in between these 2, that's not 2 pi. So I have to like write a separate one. Like I'll hit it 7 pi over 6 and then plus 2. If I went around 2 pi, that would be just once around. Hit it again. Every 2 pi, I'm going to keep hitting that spot. And same thing with this over here. So I had to write it 2 times. That was just a special case where I could just write it pi times n. And that just happened to be because it's here, and they're exactly pi apart.